A 76 kilogram person is on a 45 kilogram boat with both initially at rest. If the person jumps off the boat with a velocity of 2.5 meters per second to the right, what is the final velocity of the boat? Well, this is a momentum question, and momentum questions deal with what happens before an event and what happens after an event. Now I've diagrammed, I have a person here. I know something about that person. They have 75 kilograms. And I know something about the boat. The boat is 45 kilograms. And the very first sentence deals with the before conditions. So for the person, the things that are given is mass equals 75 kilograms. And I know that the velocity, initial velocity in the beginning, is 0 meters per second. On the other side of the equation, I know something about the boat. I know that its mass is 45 kilograms, and its velocity is also 0 meters per second. Well, now I can figure out momentum. The net momentum equals all the momentum of the boat plus all the momentum of the person. And so I can go 75 times 0 plus 45 times 0. And I find out that my net momentum in the beginning is 0 kilograms times meters per second. Well, that's all well and good before, but what happens after after this person has, the second sentence explains that he jumps in that direction at 2.5 meters per second. And if that is the case, I'm going to call this way positive, to the right. And in most Western societies, because you read from left to right, people kind of assume things on the right are positive. So the conditions I have now are the mass of the person equals 75 kilograms. And now his velocity, final, is 2.5 meters per second. And I'm going to call that a positive direction. The stuff that I know for the boat, though, tells me I still know the mass is 45 kilograms, but I don't know what its velocity is. Meters per second. The only thing I know is that the net momentum in the end has to equal the net momentum in the beginning, and that is the law of conservation of momentum. That says that the momentum in the beginning must equal momentum at the end. If that is the case, that means that the total momentum at the end is 0, which equals 75 times 2.5 plus 45 times this velocity, which I don't know, so velocity of the boat. If I simplify this, I find that 0 equals 187.5 plus 45 velocity of the boat. I'm going to subtract 187 from the right side and subtract 187.5 from the left side, giving me negative 187.5 equals 45 velocity. When I divide by 45, I get a velocity of the boat equals negative 4.16666. And so it would respond negative 4.17 meters per second. Now, before you go, Mr. Fay, I don't understand why it's a negative. The reason it's negative is because the boat is traveling in this direction, which is opposing the direction that the man was traveling in.